Welcome to The Explainer, where we make complex stuff, well, simple. And today, we're taking a look under the hood of the very thing you're probably watching this on.
So you use one of these every single day, right? A laptop, your phone, maybe even a classic desktop like this one. But have you ever actually stopped to think, what is really happening inside this thing? When you click a mouse or type a sentence or stream a video, what's the magic making it all work?
Well, today, we're going to find out. We're doing a full-on digital anatomy lesson. Yep, we're going to open the virtual hood, get our hands dirty, and see exactly what makes these incredible machines tick.
All right, here's the game plan. We'll break it down into 5 parts. First, what even is a computer? Then we'll look at its core parts, meet the brain of the operation, the CPU, figure out its 2 types of memory, and finally, see how it actually talks to us. Let's get started.
All right, first things first. Let's get a really basic definition down. What exactly is a computer when you strip it all away? Okay, so at its very core, a computer is just a really, really fast data processor. I mean, the name itself comes from the word compute, to calculate. But it's so much more than a fancy calculator, right? It takes in data, follows a specific list of instructions to do something with that data, and then spits out the result. And believe it or not, every single thing a computer does, and I mean everything, can be boiled down to these 4 steps. It takes in some kind of input from you. It processes that information. It gives you some kind of output you can see or hear. And it stores stuff for later. That's it. That's the whole loop. Playing a game, sending an email, editing a photo, it all comes back to these 4 things.
So here's where it gets really cool. We can actually map those 4 functions to the computer's physical parts. And honestly, the best way to wrap your head around it is to think of a computer like a body.
Think about it. We have a brain. A computer has its CPU, the central processing unit. We have our senses, eyes, ears, and the computer has its input and output devices, like a keyboard and a monitor. And just like us, it's got short-term memory for what it's doing right now and long-term memory for everything else.
And this diagram? This is pretty much the fundamental blueprint for every modern computer. You've got your input devices feeding information in, output devices sending results out, and right in the middle, you have the CPU and the memory doing all the heavy lifting. And the magic glue holding it all together is something called the system bus. It's like a superhighway that lets all the parts talk to each other.
Okay, let's zoom in a little further. It's time to meet the single most important part of this whole setup, the central processing unit, or CPU. If the computer is a body, this is without a doubt the brain.
It's wild to think that this tiny little chip, seriously, it's often no bigger than a postage stamp, this is the command center for the entire machine. It's the part that reads and carries out all the program instructions, does the math, and basically plays air traffic controller for everything happening inside the computer.
But the CPU isn't just one thing. It's really a team of 2 working together. First, you've got the control unit, the CU. Think of it as the project manager. It fetches instructions and coordinates the whole show. Then you have the arithmetic logic unit, the ALU. This is the calculator. It does all the math, adding, subtracting, and all the logical comparisons, like, is this bigger than that? This is where the actual number crunching happens. And this diagram here shows that little partnership perfectly. Let's say you want to add 2 numbers. The control unit, the manager, goes to memory and grabs the add instruction. Then it tells the 2 numbers to head over to the ALU. The ALU, the calculator, does the addition. And finally, the control unit takes that result and sends it right back to memory to be stored. It's this beautiful, efficient little dance that happens millions of times a second.
So that whole dance we just talked about, well, it relies on the CPU having a place to grab instructions from and a place to put the results back into. And that place is the computer's memory. And yeah, just like our own memory, it basically comes in 2 main types.
We're talking about RAM and ROM. And while they sound similar, they do 2 totally different jobs.
Okay, so RAM, or random access memory, is like your brain's short-term, working memory. It's where the computer keeps all the apps and files you have open right now. But, and this is key, it's volatile. The second you turn the power off, poof, everything in RAM is gone.
ROM, on the other hand, read-only memory, that's more like the computer's basic instincts. It holds the permanent, unchangeable instructions it needs just to wake up and start running. It's non-volatile, so it remembers even with the power off.
And that brings us to a really important distinction. You have main memory. That's RAM and ROM. It's super fast, and the CPU can talk to it directly. But it's mostly temporary. Then you have secondary memory. Think of your hard drive or SSD. That's for permanent, long-term storage. It's a bit slower, and the CPU can't access it directly, but this is where your files and programs live safely when the power is off.
Okay, last piece of the puzzle. How does this amazing brain actually talk to us, and how does it save things for good? Well, this is where its senses come in. All those input and output devices. I mean, just think about how you use your computer. You put information in using a keyboard, a mouse, maybe a scanner. Those are its input devices. And it gives information back out to you through a monitor, a printer, or speakers. Those are its output devices. It's that simple, really.
And for saving all that information permanently, wow, have we come a long way. You just have to look at the incredible jump in capacity. We went from floppy disks that could barely hold a single high-quality photo to hard disks that now store thousands of movies and massive programs.
Yeah, let's just sit with that for a second. 1.44 megabytes. A standard floppy disk, which for years was the way to move files around, held just 1.44 megabytes. Today, that's like one decent photo on your phone. It's just incredible to see how much things have changed. So when you put it all together, input, processing, output, and storage, you get this simple, elegant structure that's behind all of modern computing. Seriously, from a massive supercomputer all the way down to the smartphone in your pocket, they all share this same basic blueprint. A brain, some memory, and a way to sense the world.
And that leaves us with a really fascinating question to think about. This fundamental design, brain, memory, senses, it hasn't really changed in decades. It's been the bedrock of everything. But with things like AI and quantum computing on the horizon, which part of this digital anatomy do you think will be the first to be completely reinvented? What's the next big leap?